Good morning, good afternoon, and good evening. Welcome back to Chapter 10. We're talking about transcription and translation. We just got done talking about these things called codons. A codon is a set of 3 bases in a row that ask for one particular amino acid. There are about 20 different amino acids, and there's about 64 different codes. We likened that to helpers in a kitchen, and that the amino acid is the ingredient. A cup of carrots, a half a cup of diced onions, a bowl of watermelon, whatever. So the ingredient is the amino acid. The code is the person who's responsible for bringing that. And if it is, there are 6 different people that might be responsible for chopping onions. And all the chef has to do is yell for one of them. And he or she will bring that one ingredient that they're only responsible for, and that's the only ingredient they're ever responsible for. Sarah is only responsible for a cup of chopped carrots. She's not the only one responsible for chopped carrots, but that is all she does. And so when she hears her name, she brings the ingredient that she's supposed to bring, and the chef uses it as he's making his creation, as he's following the recipe so that he can end up with a finished product. This is called translation. The chef reading the recipe, hollering for ingredients, putting the ingredients together is called translation. Transfer RNA, that's Sarah, or Jeff, or Taylor, or Amanda, or Sherry, or whoever it was that we called for, all right? Transfer RNA, that is the helper who brings the ingredient, the specific ingredient that has to go next in line. All right? Transfer RNA brings the specific amino acids. Anywhere in my notes that you see AA, it always means amino acid. Transfer RNA brings the specific amino acid required to make the protein. Transfer RNA possesses the anticodons that match the codons on RNA. So, example. If I've got a code, here's my piece of messenger RNA. I have artificially separated these into 3s, so we know we're supposed to read them 3 at a time. It's not separated like that on the messenger RNA. It's just like teeth on a comb. It's just all one big line. But if this is an A and a U and a G, well, what is the RNA opposite of this code? What is the RNA opposite of an A? Well, that's a U. What is the RNA opposite of a U? Well, that's an A. And what's the RNA opposite of G? Well, that's C. So here's my piece of transfer RNA, this little object right here. If this is a big long comb with a whole bunch of teeth on it, a piece of transfer RNA only has 3 teeth. 3 teeth that match the first 3 on this piece of messenger RNA. This is a codon, and I know you can't see very well because it's bleeding through, but these right here, that's called the anticodon. The 3 teeth on transfer RNA is called an anticodon. And this is how we know that we always bring the right amino acid, and that's because only the piece of transfer RNA that has the anticodon of UAC is going to be carrying the correct amino acid. And in this case, the correct amino acid is methionine, because remember, AUG always asks for methionine. All right? AUG always asks for methionine. So the piece of transfer RNA that can match AUG has the anticodon of UAC. Here we see my ribosome. It's like the teeth of a comb sticking up. Notice how it's different shapes. Those different shapes will represent A and U and G and C. And if this is an A, only U can match it. If this is a C, only G can match it. If this is an A, only U can match it. So the green is the anticodon. These 3 little teeth right here in a row, that's the codon. and only the piece of transfer RNA that has the matching anticodon to match the codon will be carrying the proper amino acid. These little shapes right here, that's going to become the protein. Remember, their protein is made of a whole string of amino acids. This is the beginning of that chain of amino acids. Once the ribosome, my brown little nugget here, that's my ribosome, made of two pieces, the small subunit and the large subunit. Once it has both of its active sites filled, we talked about active sites. Remember, that's a special place where something binds to an enzyme. And a ribosome is basically just a giant enzyme, and it has two active sites, one for each of these two pieces of transfer RNA. Once both of its active sites are filled, the ribosome is going to do its job. And the job of the ribosome is to break this bond right here and to make this bond right there. It is to connect this new amino acid to the growing chain that I'm making and breaking the bond between these two. Now that this piece of transfer RNA is no longer attached to its amino acid, it's going to fall out of the socket. And then it's going to go find whatever one it's supposed to attach to. Once Sarah has brought her carrots to the chef dumps the carrots into the dish, hands the bowl back to Sarah. What should Sarah do? Sarah needs to go back to her station, and she needs to chop up another cup of carrots. The piece of transfer RNA, that's Sarah. This is her cup of carrots. Well, next he's called for Jeff to bring in a half a cup of diced onions. Sarah's standing here with her carrots. He dumps the carrots in, and then Jeff shows up, and when Jeff shows up, he dumps in the onions. Now Sarah has an empty bowl. Sarah goes back to go get her bowl. The chef is holding on to Jeff's bowl of onions. He hasn't thrown them in yet. He looked at the next step in the recipe, and he sees that it's Matthew's turn, and he yells at Matthew to bring in some celery. And when Matthew gets there, he dumps the onions in. He gives the onions to, I forgot the guy's name. He dumps Jeff's onions into the dish. He hands the bowl to Jeff, sends Jeff back to his spot, and he takes the bowl of celery from Matthew, and then he looks at the next name and he hollers for the next person to bring the next. And that's how the ribosome just chatters down the line, goes down the piece of messenger RNA in a piecewise fashion. And this shows exactly what I just said. So here is my ribosome right here. One of its active sites is filled, the other one is open. This active site is holding on to the growing polypeptide. This is the dish. This right here is what I'm trying to make, this string of amino acids. The next piece of transfer RNA comes and it sits in the spot. Once it's sit in the spot, now it's the time for the ribosome to do its job. It makes a bond between this amino acid and that one. And when it makes this bond between these two, it breaks that bond right there between this piece of transfer RNA and its amino acid. Now that that bond is broken, this piece of transfer RNA doesn't fit anymore. Sarah goes back to her station to get some more carrots. Now, Jeff is holding on to his cup. The ribosome shifts over one spot, and now this spot's open. Jeff moves over one spot. This spot's open, and it's time for the next one to come in. And it just chatters down the line, putting them together one at a time, just like that. As we just said, the ribosomes attach the amino acid to the growing polypeptide. Remember, polypeptide is what you call a protein. That's not big enough yet to be called a protein. It has to be at least 50 amino acids long to be called a protein, and honestly, you don't call it a protein until it's finished. And so up until then, you refer to it as a polypeptide. So the growing polypeptide, that's this little chain right here. That is my polypeptide that's growing. That's what I'm trying to make. This is it. This is just the chef and the helpers. This is the dish. That's what they're creating.